we have a set of 5 questions of trigonometric integrals. This is exciting. Let's dive into it. The first one, integral of 7 times cosine of x dx. Let's start by getting the 7 out of the way. So we have 7 times integral of cosine of x dx. And you know, integral of cosine of x dx, what do you have to differentiate to get cosine of x? That's sine of x. And you have to end with plus c. Next one, 8 times secant of x tangent of x plus secant squared of x. Now you can get 8 out of the way. Integral of secant of x tangent of x, what do you have to differentiate to get secant of x? That's secant of x. Plus, what do you have to differentiate to get secant squared of x? That's tangent of x. So the answer is 8 secant of x plus tangent of x plus c. Next one, 1 plus cotangent squared of x dx. Let's start by dividing this. So we get integral of 1, which is x, because when you differentiate x, you get 1. And you get plus integral of cotangent squared of x dx. Do we know what this is? We know integral of cosecant squared of x dx. That's negative cotangent of x plus c. But we do not know what integral of cotangent is so far. So this doesn't seem like the right way to go. So how can we do this? We can do it by using one of our trig identities. We know 1 plus cotangent squared of x is same thing as cosecant squared of x. Now let me review some of the trig identities. We have cosine squared of x plus sine squared of x is equal to 1. And we have 1 plus tangent squared of x is equal to secant of x. You can get this from the first one by dividing both sides by cosine squared of x, and by dividing both sides of this equation, cosine squared plus sine squared is 1. By sine squared of x, you get 1 plus cotangent squared of x is cosecant squared of x, secant squared of x, and cosecant squared of x. So in this case, 1 plus cotangent squared of x gets you integral of cosecant squared of x, which you know is negative cotangent of x plus c. Let's look at the next one. Integral of sine squared of x plus cosine squared of x. I actually wrote it right here. The same thing as integral of 1 dx. We can write it as integral of dx. And what do you have to differentiate to get 1? That's x plus c. Next one looks complex, but we can break it apart. Let's start by getting 2 outside. So we have 2 times integral of sine of x, and for cosine of x, let me break it apart to cosine x. You will soon see why I broke it apart. How we can group this, so we have something inside the integral that we can actually evaluate. We can break this down into sine of x over cosine of x, which is same thing as tangent of x, and 1 over cosine of x, which is secant of x. We know what integral of tangent of x, secant of x dx is. That's secant of x. So we have 2 secant of x plus c.